Hello students, in previous video we have seen bond enthalpy and enthalpy of reaction from bond enthalpy. Also we have solved some problems on this unit. In today's video we are going to discuss about Hess law of constant heat summation. This is very important unit in this topic. Many times question is asked, state and explain Hess law of constant heat summation. What is statement of Hess law? Enthalpy change or a reaction. It is also called heat of reaction. Is equal to the sum of enthalpy or sum of enthalpy changes of individual states involved in the reaction. What is statement of Hess law? Enthalpy change for a reaction or heat of a reaction is always equal to the sum of enthalpy changes of individual states involved in the reaction. It can be explained with the help of some points. First point, enthalpy change of chemical reaction. Enthalpy change or a chemical reaction is the same irrespective of path followed or number of steps involved in the reaction. Enthalpy change for a chemical reaction is the same irrespective of path followed or number of steps involved in the reaction. As enthalpy is state function. Enthalpy is state function. The enthalpy change of a reaction depends only upon initial and final states. Initial and final states of the system and not upon the And third point, to obtain overall equation or thermochemical equation, the individual equations can be added, subtracted, or subtracted, multiplied, or divided, like simple algebraic equations. Simple algebraic equations. These are some points which are useful to explain Hess law of constant heat solution. First point, enthalpy change for a chemical reaction is the same irrespective of path followed or number of steps involved in the reaction. Second point, as enthalpy state function, its magnitude depends only upon initial and final states of the system and not upon number of states followed or path followed between these states. And to obtain overall thermochemical equation, individual equations can be added, subtracted, multiplied or divided by any integer like simple algebraic equations. Hess law can be illustrated with the help of an example illustration. Consider synthesis of ammonia. Synthesis of ammonia from hydrogen and nitrogen gases. Synthesis can be brought about either in one step or two steps. In two paths. Path first, one step, synthesis of ammonia. Nitrogen and hydrogen gases in 1:3 proportion. When mixed together, they give ammonia gas. And enthalpy change of this reaction is minus 92.2 kilojoule. This is one way of synthesis of ammonia. Second part, ammonia can be synthesized in two steps. Two-step synthesis of ammonia. In this step, first of all, nitrogen gas is mixed with limited amount of hydrogen to produce N2H4 nitrogen hydride gas, and enthalpy of this reaction delta R H naught is plus 95.4 kilojoule. Then in second step, nitrogen hydride gas is treated with excess of hydrogen to give ammonia gas. This is second step. And enthalpy change of this reaction, say it is enthalpy change for first reaction delta R H1 naught, and enthalpy change for second step delta R H2 naught. It is minus 187.6 kilojoule. It is observed that if you add these two steps, you will get overall reaction. Here N2H4 cancels and we get N2 gas plus 2 plus 1 H2 means 3 H2 gas to give twice NH3 gas. This is overall reaction to be required, and enthalpy change of this reaction is delta RH naught 1 plus delta RH naught 2. Here you can have delta RH naught, it is minus 92.2, that is equal to plus 95.4 plus into bracket minus 187.6. If you solve this, you will get minus 92.2 is equal to plus 95.4 minus 187.6 minus 92.2 is equal to minus 92.2. Both sides are same. Hence, Hess law constant heat summation is proved. This is illustration for Hess law. Synthesis of ammonia either in one step by path first or in two steps by path second. It is observed that enthalpy change of this reaction is equal to sum of enthalpy changes of individual steps, first and two. It is proved by this calculation. Now next point we have to discuss about Hess law. It is application of Hess law. There are many applications of Hess law, but here only one is important. Hess law is used for to calculate the enthalpy changes or reactions with their enthalpy being not calculated experimentally. Hess law is useful to calculate enthalpy of those reactions whose enthalpies cannot be calculated experimentally. This is about Hess law. Now we have to discuss about problems on Hess law. Numericals on Hess law. First problem, calculate delta H naught for the reaction. Reaction is given twice S3 BO4 aqueous to give B2 O3 solid plus 3H2O liquid. This is the reaction, and to solve the problems, some equations are given. First, S3PO3 aqueous to give SbO2 aqueous plus H2O liquid, and enthalpy change of this reaction delta H1 naught is given minus 0.02 kilojoule. Second equation, H2 B4 O7 solid, it gives twice B2 O3 solid plus H2O liquid, and enthalpy change of this reaction delta H naught 2, it is given 17.3 kilojoule plus, and third equation is given H2 B4 O7 solid plus H2O liquid, it gives 4 HbO2 aqueous, and enthalpy change of this reaction delta H naught 3, it is minus 11.58 kilojoule. These three thermochemical equations are given, and from these equations we have to obtain this equation, and whatever processes we carry out on these equations, same processes are carried out on enthalpies, corresponding enthalpy. Now solution. Required equation is what? It is given twice S3 BO3 aqueous to give B2O3 solid plus 3H2O liquid, and we have to calculate enthalpy of this reaction. To obtain this equation, following processes are carried out. to obtain above equation. First, multiply equation A. Multiply equation A by 2. Divide equation B by 2. Reverse equation C and divide it by 2, and finally add all the modified equations. Now by seeing this equation, you can carry out different processes on the given equations as given on the blackboard. Now, how modified equations are obtained? First, multiply equation A by 2. That means you have to multiply this whole equation by 2 along with enthalpy. We get 2S3BO3 aqueous to give twice HbO2 aqueous plus 2H2O liquid, and enthalpy change of this equation is also multiplied by 2. It becomes delta H1 naught is equal to minus 0.04 kilojoule. If you multiply this value by 2, you will get minus 0.04 kilojoule. Second, we have to divide equation B by 2. That means we get 1 by 2 H2 B4 O7 solid to give twice B2 O3 solid plus 1/2 H2O liquid. If you divide this equation by 2, you will get 1 by 2 H2 B4 O7 plus B2 O3 . One half H2O liquid, and enthalpy change of this reaction becomes 8.65 kilojoule. And third equation, we have to reverse this equation, that means products are written as reactants and reactants as products. That means you will get 4 HbO2 aqueous to give H2 1/2 H2 B4O7. Here you have to reverse this and again divide by 2. You will get 2 HbO2 to give 1/2 H2 B4O7 plus 1/2 H2O liquid. And the enthalpy change of this reaction delta H naught 3 is minus 5.79 kilojoule per mole. Now you have to obtain this equation. Here 1 of H2B4O7 is cancelled with this. Twice HbO2 is cancelled with this. Here we get this 2B2O3 on division by 2 becomes B2O3. You will get twice H3BO3 aqueous to give B2O3 solid plus. Now here 3 H2O are there. That means 2 plus 1 half 1 plus 2 3 H2O liquid. We get required equation, and on algebraic sum we get delta H naught of this reaction as plus 14.4 kilojoule. This is the answer. In this way, we can solve the problems on Hess law constant in summation. In next video, we will discuss about some more problems in this respect. Thank you.